Welcome to 3.07 Combined Functions. Just two goals today. Be able to add, subtract, multiply, and divide two functions. That is the main thing you're going to do. You'll be given f of x and g of x, two functions, and be asked to perform those four operations. Our second goal, interpret a function that results from combining two functions with a function operation in terms of the context of the situation. What that really is talking about is the notation you see here, which is four different ways we might see these operations be shown. Actually, two for each, right? So adding, subtract, multiply, divide. Let's take a look. What's going on the left side of all of these equal signs? That is where we're being told what's happening. We're going to add function f and g, and then of course of x, because you can plug in different x values and see what you get out. But on the right, we're also showing the same thing in a different way. So when you're asked questions about combining functions, it's going to be asked as you see here in these highlighted areas. And then when you set it up, it'll be nicer and cleaner to set it up like you see on the right here, right? Write your first function plus write your second function, write your first function times write your second function, and so on. Let's practice. Here we're asked to find the sum, difference, product, and quotient of f of x and g of x, exactly what our goals want us to do. Okay, f of x is the function x squared minus 4, and g of x is x minus 2. And over here, what are we being asked to do? F plus g of x. So we're being asked to add f and g. We can rewrite it like this, and then substitute in the actual functions themselves. Okay? Now, when we do that, what do you see here that you don't see up there? Parentheses, right? Anytime you substitute, use parentheses, even if they're entire functions, because it avoids mistakes, okay? For adding and subtracting these top two, the process is exactly the same. You put each function in parentheses, put your plus or your minus in between, depending on what they're asking you to do, and then distribute that plus sign. So plus x, positive times negative, minus 2, and then you combine like terms, right? You'll have x squared and x. Those are not like terms, so those stay as they are. And then you have negative 4. Again, we just said when you distribute this, you'll have negative 2. So negative 4 minus 2 gives you negative 6. And we are done. You're not asked to factor. You're not asked to plug in an x value or find solutions. That is pretty nice, right? We're just combining the functions. Subtracting, same thing. Distribute that minus, combine like terms. For f times g of x, same thing. Write it out. F of x times g of x. And what do we do? Well, we have two binomials. How do we multiply two binomials? The box method or FOIL, but I prefer box method. Two terms times two terms, so two columns and two rows. Then we multiply what's on the outside to get what's on the inside, right? And then we get all these four terms and combine like terms if possible. Well, here there are no like terms, so we just write out all four, and that is our combined function. Fortunately, up until this point, we haven't had to factor, but the good news is you've had a lot of practice factoring. And in this, when you're dividing, you're going to need to factor a little bit, because remember, in order to cancel out, well, I'll rewind. In order to simplify a fraction, you need to cancel out anything that can be canceled out. And to do that, we need to factor because you can only cancel out factors in a fraction. The denominator, that is as basic as can be, that is a factor in itself. The numerator, though, is a difference of squares. Don't forget your difference of squares pattern. If you have a perfect square minus a perfect square, you can write it as the square root of the first term. So square root of x squared is x plus and then minus the square root of the last term. Square root of 4 is 2 and 2. And it's always plus and minus. Now what do we have? We have more factors, don't we? We have common factors more specifically, so these cancel out, leaving you with an answer of x plus 2. But that's not all. We have to also say this. Do you know why? We'll take a look back at what we did. Think about what would happen. Would this answer be the same if x was 2? No, right? Not at all. Look right here. X minus 2. We'd have 2 minus 2. We would have a denominator of 0, and you've learned that means it's undefined. We would not have an answer of x plus 2. So this is another way of saying, our answer here is saying the answer is x plus 2 as long as x does not equal 2. Okay. Now is a time for you to practice all 4 operations with these 2 functions. Now, they're not too long, they're not too complex of functions. They're similar to these, but slightly different. Okay, now let's do it together. First, we are adding f. I'm going to get used to writing the notation, and you should too. F plus g of x is f of x plus g of x. Double check your signs, your parentheses, everything. Are we adding? Yes, we are. Good, good. Okay, we need to distribute this plus 1 to both terms, right? You can't have positive 0. This is positive invisible 1. And this is not going to multiply with anything, so we can get it out of the parentheses, giving us what we see here. And we combine like terms. Well, the only like terms are -1 and -1. So if we put those together, we get -2. B, very similar. We're subtracting f minus g of x. Same setup, just a minus in the middle. And here we go, distribute. So free this from parentheses, distribute -x plus 1. That gives us x squared minus x. And look at this, these are opposite signs, so that goes away. 2 down, 2 to go. F times g of x is f times g, or f of x times g of x, however you like to say it. But there we have it. We have 2 binomials. Okay, so again, box method. We also have a difference of squares there, which is interesting, but let's just use the box method for now and see what happens. We get x cubed minus x squared plus 1. No like terms, right? So we get x cubed. Remember, decreasing exponential order is how you write this out properly. And finally, we have D. F divided by G of X. Here we go. we get x squared minus 1 over x minus 1. So tempting to cancel these out, right? But they're not factors. Like -1 and -1, those are not factors. We can't just cancel that out. X squared and x on their own are not factors. Okay? This entire denominator is a factor. And we just noticed a moment ago that the numerator is once again a difference of squares. So to factor a difference of squares, you're going to have two sets of parentheses. It will always be plus and minus. Square root of the first term, square root of the second term. Square root of 1 is 1, right? Because 1 times 1 is 1. All over x minus 1. You can put that in parentheses or not, but it's a factor. Cancel them out, and we get x plus 1. And that is actually it for today, I believe. Let me see if there is more practice. There is. Why not get a little more practice in? Now is a good time. And let's do these together because these functions are a little different, right? So let's get some more good practice in. Here we go. I'm not going to write out all the notation this time. I'm just going to write out A. So what do we have? We have f of x plus g of x. Free the parentheses, distribute the plus, combine like terms. X squared, these are like terms. And these, I'll use a squiggly line. These are like terms. Interesting. This is a very interesting quadratic as well, but all we're asked to do is combine them and simplify. So we're done with A. Let's move on to B. A lot of this is the same. Remember, distribute that minus, combine like terms, we get x squared, 7x minus x this time. That's a 6, and then 12 minus 4, that's 8. If you haven't tried C or D, now is a great time for you to do that. Okay, let's do it together. Let's see how you did. C is multiply. Okay, there's a lot of terms here. We're going to multiply. We have a trinomial times a binomial. So I'm going to set up my box method with 3 columns for the trinomial and 2 rows for the binomial. Let's put it all together. You could write your pluses, but you don't have to. As long as there's no negative sign, we know it's positive. And we multiply. And multiply and multiply. Keep going. 48. Okay. Double check. It's always good to do that. And pull out your terms. I'm going to combine like terms. So I see the x squareds, 4 plus 7, 11. 28 plus 12, 40. And 48. Like terms are combined. Question C is answered. One more question here for today. Divide. Now I am running out of space very quickly. So let's see if I have more room. Here's more room. let's do the divide. We have f of x over g of x, and we need to factor this quadratic. Fortunately, it's a leading coefficient of 1, so the x method should work. It doesn't always, but let's see. A times c and b. Factors of 12, 4 and 3. Well, those add to 7. That was easy. So we factored out that numerator already. X plus 4 times x plus 3 over x plus 4. Cancel common factors. And x plus 3 is our answer. And we are done.